Guys, welcome to the second part of the lecture, and let's dive right into the differential equation problems. Okay, now let's solve the mountain problem. So we brought this fellow in and asked him to take a very close look at every part of the mountain and tell us what is the derivative of the function which defines the height, or essentially what is the slope of the mountain. So we ask him to take a look at every point here and tell us the slope. Okay, and he does so. He takes a look at the mountain very closely and tells us that wherever he looks, for every x, the derivative, the slope essentially, is equal to 1. Alright, what is more, we know that our mountain is somewhere between 0 and 1, that is given 2. So all the x's are between 0 and 1. And we knew something else too. If we wanted to find the function f of x, which defined the height, from this equation, we needed to know something about the boundary. So we essentially needed to know the height at the very beginning, and then we added it up with the amount that we go up. So that boundary condition should also be given, and it is here. We'll say that the height at the very beginning of the mountain is equal to 1. Okay, now let's take a look at the problem from a mathematical point of view. We have an equation in which the derivatives of the function exist. Here only the first derivative. This equation is called the differential equation, simply because the derivatives exist. The solution to this equation is a function, here f of x. F of x is defined in a domain which is predefined, and here is given as between 0 and 1. And to find a unique solution, we would reach there. I will explain what it means to have a unique solution. To have the solution, we need to know something about the boundary conditions too. Here, the value of the function at the very beginning of the domain 0 is set to 1. Okay, now we can solve this problem. Let us use the equation that we derived at the end of the previous lecture. I'm going to write it out again. We had f of x, that's what we wanted to find, equals to f at the very beginning, f of 0, plus integral of 0 to x, f prime of x dx. That was the equation that we found previously. And I'm going to insert f of 0 in here and f prime of x in here and do this integration and find the value of f of x. Okay, so let's insert the values. F of x is equal to, let me go down here, f of 0 is equal to 1 plus the integral of 0 to x, and f prime of x was equal to 1 dx. Okay, let's do this integration. Let me write out 1 and then plus. Okay, so what is the integral of 1? It is 0. It is, sorry, x. And whenever you do the integration, just do the differentiation, the reverse action too, so you make sure that you have the right value. So what is the derivative of x? That's 1. So we did it right. Okay. And we should put the bounds here too. So the value of integral from 0 to x. Okay. And hopefully you already know how to insert this bound into here. We have, let me write out this 1 here, plus you would first put the upper bound in here, insert the upper bound, so we have x, and then subtract the value of the lower bound when it was inserted. So we put x 0 into x, which is 0. Alright, so now our f of x becomes, go up a bit, okay, value of f of x becomes 1, oh right here, 1 plus, and this is just x. Pretty cool. We found the solution to our differential equation problem. Now there is a very important task remaining. You should validate this solution. So we found the solution, but it is just not enough. What you need to do is to make sure that this is actually the solution that we were looking for. So for instance, you have to insert it in our differential equation, the one that we had here, this guy, insert it in here, and make sure that this equation is valid. And what else you need to do is to insert it in the boundary condition. There were equations too. You can put this function into them and see that they're actually satisfied. Here we had abstract mathematics, but later on during the course you have actually mechanical problems, so you can go ahead and check the units. So for instance, if this function, for instance in this example, the function was height of the mountain, so if the units turn out to be Newton, then you did something wrong. And you can go on and do any other check which is logical, and make sure that your solution is actually valid. So I would leave it to you guys. This would be exercise number 1. Do this yourself. Make sure that this is actually the solution.